Section 6.3 is on reflections, and this one we're going to reflect a point, segment, or a shape over a line of reflection. So a line of reflection, this is the same distance, or in the middle, of the image and pre-image. So it's the same distance away from the image as it is away from the pre-image. So for this lesson, you're going to need to know how to graph vertical and horizontal lines. So a quick review, vertical lines are going up and down, and those equations are always going to be an x equals a number. And horizontal lines, those are going left and right, and those equations are always going to be y equals a number. So an example, if we had an equation x equals 4, that would be, we would go on the x-axis where x equals 4, plot a point, and then we would just draw a line going straight up and down through that point of x equals 4. And then if we had an equation y equals -2, we would go to the y-axis where y equals -2, and then we would draw a horizontal line. And on this line, every point is going to have the y-coordinate of -2. Okay, so looking at our first example, the vertices of triangle ABC are given, and they want us to reflect over the line x equals 2 and y equals 3. And we're going to do this on two separate graphs. So why don't you go ahead on both of your graphs, plot the points for the triangle on both of them, and then we will go over how to do the reflections. All right, so this first one, we're going to go over the line x equals 2. So I'm going to go on my x-axis where x equals 2, and I'm going to plot my first point. And that is where the line is going to go through vertically, up and down. So now we're going to reflect it over this line. So to do that, we are going to count the distance from each point to that line. So if we start with point A, that is one space away from the equation of x equals 2. So we're going to go one space in the opposite direction on the other side. And that is where A prime is going to go. Then we would do the same thing for C. We count the number of spaces it's away from the line, which is 3. And then we would go 3 in the opposite direction. And that is where we would plot C prime. And same thing for point B. That's one space away from the line, so we would go one space in the opposite direction. And that is where we would put B prime. And once you have that all drawn out, you can connect your points for your triangle. So that's how you're going to reflect over a vertical line, and the rules are the same for a horizontal line. So for the second graph, we were told to go over the line y equals 3. So we're going to graph the line of y equals 3. So first thing on my y-axis, I'm going to plot a point at 3, and that's where my horizontal line is going to go through. So why don't you pause the video and go ahead and reflect the triangle over this line, and then hit play to check your answers. So for this one, A was one spot away, so A prime would go over here. B was 3 spots away, and you would have noticed that this one does go off the graph a little bit for B prime. And C, that was right on the line, so it is okay if C and C prime are in the same spot. That does happen sometimes when the line of reflection goes through the image we are reflecting. So that is where our new coordinate points would be. So if you got that right, you can continue on. If not, pause the video so you can fix your answers. So then we also have example 2. This time we have a line segment CD with C at -2, 2, and D at 1, 2. And we are going to reflect this over the line y equals x. So if x equals 0, that means y would equal 0. If x equals 2, y would equal 2. If x equaled -2, y would also equal -2. So you'll notice that this is going to be a straight line going up 1 over 1 because it has that slope of up 1 over 1. So we need to reflect it over this line. So when our line is not horizontal or vertical, we are going to follow a few different rules. We are going to first count down or up until we get to the line of reflection. So for this one, we're going to count down. So in this example, we went down 1, and then we're going to go the direction that gets us to the other side of the line. So that would be right in this instance. And we're going to go the same amount that we just moved. So this is where D prime is going to be. Then if we do the same thing for C, we count that we went down 1, 2, 3, 4. So then we need to go 4 to the right. And that is where C prime would be. And you'll notice this is still 3 units long, just like it was before we reflected it. And we're going to do the same thing in this next example. So we're using C at -2, 2, and D at 1, 2. And we are going to be reflecting this over the line y equals -x. So if we had x equals 0, y would equal 0. If we had x equals 2, y would equal -2. If x equaled -2, y would equal 2. So this one, instead of going up 1 over 1, we are going to be going down 1 to the right one. And knowing how to graph these lines will be important. There will be 1 or 2 on the test where you have to graph these slanted lines. And there we go. So now we're going to follow the same rules that we did in the example 2. We're going to count down until we get to the line of reflection and then go to the direction that gets us to the opposite side of that line. So why don't you go ahead and do that for this example and press play when you have it done. So if you did this for point D, you should have went down 3 and then to the left 3. And that is where D prime would be. So at -2, -1. And you'll notice for C, that's already on the line. So C prime is just going to be in the same place. That one doesn't move. So this would be your final answer for D prime and C prime. And one thing I want to note, even if these are in the same point, you do need to label them with both C and C prime, just so that I know you knew that it didn't move. Okay. So then the last thing we're going to do are example 4. And there will be one similar to this on the test. So this one says tools workers are retrieving tools that they need for a project. One will enter the building at point A and the other at point B. Where should they park on the driveway M to minimize the distance they will walk? So the very first thing you're going to do for problems like this you're going to reflect one of the points. It doesn't matter which one, you can choose any. So for this one, I'm going to reflect point A. So I'm just going to kind of estimate where that's going to go down here. So point A prime would probably be about there. So once you've reflected that point, you are going to connect the reflected point with the non-reflected point. So we are going to be connecting point B. This would be the non-reflected point. And this would be our reflection. So maybe we'll relabel this as reflection. So your reflection point with a non-reflected point. So we're going to connect those. And the reason that this is helpful is because the shortest distance between 2 points is a straight line. So we want to make sure that the place that we park is going to be the shortest distance combined for both people. And in this, we know that from A to the line segment is congruent from the line segment to the reflection of A. So we just moved that point down so that we could draw a straight line to see where it's going to be the shortest distance. So this point that I'm just going to label C, that is where they should park their car, and that's going to give them the shortest distance. So that's everything you need to know for problems like this. There are some on the homework that you're going to use a graph for, and you're just going to reflect those over the x-axis instead of a line M. If you have any questions, though, let me know, and I'll get back to you as soon as possible.